Hi everybody, Mrs. Bolin here, and this is the second video for Learning Target 7.5. I can factor quadratic trinomials completely. In part one, we talked about the different steps to do this, and then we also had plenty of practice using X method, so seeing what that looks like. And so in this part two video, we're actually going to put all the steps together now that we have some practice with our step two, just doing the X method portion. We're going to put it all together. So on the back side of our notes today, we will first factor out the GCF. Second, we will use that new X method that we learned. And lastly, we'll be able to factor by grouping. So if we check out the back side, our directions tell us to factor each completely. And so for example one, the first thing we can do according to our directions is see if there's a GCF we can pull out, a greatest common factor. And looking at these coefficients of 2, 11, and 9, there's not a number I could pull out of them. And they don't all have a variable term, so there's no GCF. So on to step two, I'm going to use the X method that we learned. And notice we have a trinomial. It's quadratic, meaning we have an x squared term. And we can identify, because it's in standard form, A, B, and C, and I'm actually just going to label them above. So A is 2, B is 11, C is 9. And right here I'm going to create my X. In the top I need to do A times C, which is 18. So I'm going to be looking for two numbers that multiply to 18. In the bottom you put your B, which is 11. And so those same two numbers need to add to 11. So what you need to do is think of numbers that multiply to 18. So for example, 18 times 1, but there's no way you could add 18 and 1 to get 11. Or maybe you're thinking 6 times 3, but there's no way we could add 6 plus 3 to get 11. 9 and 2 does work, because 9 times 2 multiplies to 18, and 9 plus 2 adds to 11. So I just found the two numbers that I need to use to split this middle term. This 11x is going to be split into 9x and 2x. So I'll rewrite it. I have 2x squared. Instead of writing 11x, I'm going to split it into 9x and 2x. So plus 9x plus 2x. Don't forget your plus 9. And now I have 1, 2, 3, 4 terms. And now I can do my last step, which is factor by grouping. And this is what we did in a previous learning target, where we will split our polynomial into two halves, first half and second half. So just looking at my first half, what is my GCF that I could pull out? So I can't pull a number out of 2 and 9, but I can pull an x out of x squared and x. So my GCF for the first half will be x. And now it's like backwards distribution. I'm saying x times what gives me 2x squared? That would be 2x. And x times what gives me 9x? That would be 9. Now for the second half, I can ignore the first half, and I can't pull a coefficient out. I also can't pull a variable out. So when you can't necessarily pull out a GCF like that, you can always just say it's plus 1. You can pull out a 1. So it's going to stay 2x plus 9. 1 times 2x plus 9 gives us 2x plus 9, right? You can go through the distributive property if you want, but 1 times anything is leaving it unchanged. So now to finish up the factor by grouping, I should notice that I have a common polynomial factor here. This has to work out to be the same. If it doesn't, then you made a mistake. So I can pull out that common polynomial factor, which is 2x plus 9. So that would be one factor. And then my leftovers, those are the other factor. I'm left with an x and a positive 1. So those would be my two factors, 2x plus 9 and x plus 1. Let's take a look at example 2. So in example 2, first thing I should do, check to see if there's a GCF that I can pull out, and the answer to that is no. There's no number I could pull out of 5, 18, and 16. So I can identify my A, my B, and my C. I can do my X factor here. So I'm looking for A times C in the top. So 5 times 16 gives me 80. So I need two numbers that multiply to 80. In the bottom, I put my B, which is 18, and I need to add to 18. So I need to start thinking of multiples of 80. Right away, I think of 8 and 10. Let's see, 10 times 8 gives me 80, and 10 plus 8, perfect, adds to 18. So I found my two numbers, 10 and 8. So this means I'm, again, splitting the middle X term. In this case, 18n, I'm going to split 18n into 10n and 8n. So I'll rewrite it. I have 5n squared plus 10n plus 8n. Don't forget your plus 16 at the end. When I wrote 10n plus 8n, if you switch the order here, that's totally fine. You'll get the same answer in the end. So I could have written 8n plus 10n, that's fine. So I did the X method. Now I'm going to split it up to factor by grouping now that I have 4 terms. So looking at just my first half, what's my GCF for 5n squared plus 10n? Well, I can pull a 5 out of both 5 and 10, and I can also pull an n out. So my GCF here is 5n. Now you have to think of it as like backwards distribution. 5n times what gives me 5n squared? That would be n. 5n times what gives me 10n? That would be 2. My second half, I'll be able to pull out an 8 here. And then you should be noticing a pattern. We have to have a common factor here, so you can kind of keep that in mind. 8 times what gives me 8n? 8 times n gives me 8n. And 8 times 2 gives me 16. Worked out perfectly because I have a common polynomial factor, n plus 2. And then my leftovers, they give me my other factor, so 5n plus 8. And those would be my two factors. I've completely factored this quadratic trinomial. Let's take a look at example 3. Is there a GCF that I can pull out there? Let's see, I can't think of a number that goes into 2, 17, and negative 30, so nope. So I'm gonna have my A, my B, and my C. And set up my X method here. So 2 times negative 30 gives me negative 60. So I'm looking for two numbers that multiply to negative 60. They're going to add to 17. So I need to start thinking of multiples here. I know 10 and 6 multiply to 60, but there's no way I'll be able to add those even considering the negative to get 17. Other numbers that multiply to 60, I think of like 20 and 3. Yes, and there's a way I'll be able to manipulate those to add to 17. So the numbers are going to be 20 and 3, but one of them has to be negative if it's going to multiply to a negative 60. And the way we determine which one is negative is because when added, they have to add to 17. So that means our 3 is going to have to be negative. 20 times negative 3 multiplies to negative 60. 20 plus negative 3 adds to 17. So I'll split up my middle term, 17p, into 20p and negative 3p. So I have 2p squared plus 20p minus 3p minus 30. Now I have 4 terms. I can split it up to factor by grouping. Be very careful right away when I'm splitting it up. I'm noticing that my third term is negative. So when we get to that part, remember that when your third term is negative, you have to pull out a negative there. So in my first half, my GCF is going to be a 2p. 2p times p gives me 2p squared, and 2p times 10 gives me 20p. Now looking at my second half, my third term is negative, so I know right away I will have to pull out a negative there. And my GCF here will be pulling out a negative 3. Negative 3 times p gives me negative 3p. and negative 3 times positive 10 gives me negative 30. Perfect. I have a common polynomial factor. It has to be exactly the same if we're going to factor it out. So our common polynomial factor that we could factor out is p plus 10. And then my leftovers, I have a 2p and a negative 3. That would be my second factor. All right, last example before you try some on your own. So in example 4, let's see, is there a GCF we could pull out? I'm noticing some large numbers here, 45, negative 145, and 30. So this is one we can make a note. We're going to factor out a GCF first. And kind of a giveaway is when the numbers were so large, chances are we'll be able to factor out a GCF. So what number goes into 45, negative 145, and 30? That would be 5. I factored out a GCF of 5, and now I need to think of backwards distribution. So 5 times what gives me 45m squared? That would be 9m squared. 5 times what gives me negative 145m? That would be negative 29m. 5 times what gives me 30? That would be 6. So this 5 that we've pulled out as a GCF, we're just going to have to remember every step to continue writing the 5. So here's my trinomial. So here's my A, my B, my C. So I can set up my X method now. In the top, I'm doing A times C. 9 times 6 gives me 54. So I'm looking for two numbers that multiply to 54. They're going to add to negative 29. So I need to start thinking of numbers that multiply to 54. I know 54 is even, so that would be what, 27 and 2. So 27 times 2 gives me 54. Oh, but also negative 27 and negative 2 would turn to a positive 54. And negative 27 plus a negative 2 adds to negative 29. So again, you might just need to use your calculator. It might be guess and check, but this means I can split up negative 29m into negative 27m and negative 2m. I do need to remember to bring down that GCF of 5. That's just along for the ride. I have to continue writing it. And now I can write 9m squared. I'm splitting up the negative 29m into negative 27m and negative 2m. Don't forget to bring down your plus 6. And then I'm just grouping it inside parentheses since I did pull out a GCF of 5. Now I can factor by grouping here. So I can look at first half and second half. So again, I can pull down the 5. GCF for the first half, let's see, I can pull out a 9m. 9m times m gives me 9m squared. 9m times negative 3 gives me negative 27m. Now looking at my second half, notice my third term here is negative. So I know right away we'll have to pull out a negative. My GCF for the second half is a negative 2. Negative 2 times m gives me negative 2m. And negative 2 times negative 3 gives me a positive 6. Look at, I do have a common polynomial factor. So that worked out perfectly. So my common polynomial factor, m minus 3. I'm going to bring down that 5. That was our GCF that we pulled out at the very beginning. And then my other factor is the leftovers, 9m minus 2. All right, at this time, you have 4 U-tries. So I'd like for you to go ahead and see what you come up with. Go ahead, pause the video. On the first U-try, my factors were x minus 3 and x plus 2. Second U-try, I got n minus 10 and n minus 5. Third U-try, I got a plus 3 and 5a minus 2. Keep in mind, if you had these two factors in reverse order, that's totally fine. You can definitely have them switched as long as you have the factors there. And then the last U try was the most difficult because you had to notice that there was a GCF of 4 to pull out. So you should have pulled out a GCF of 4, and then you would be left with 3b plus 2 and 3b minus 1. Let's say you didn't notice at the beginning that you could pull out a greatest common factor of 4. At the end, one of your factors would not be simplified. It wouldn't be factored completely, meaning you would be able to pull out a GCF. So notice your factors should always be simplified, as in there's no GCF that you can pull out of them. That's why I always recommend at the beginning of the problem, check all of your terms to see if you can pull out a GCF.